Hi, welcome to Number Club. This is Year 1 Pure, Chapter 2, Lesson 4. Today we're talking about quadratic graphs. Let's get cracking. So, this question says, sketch the quadratic indicating all intersections with the axes, the turning point and the line of symmetry. Now, this was sort of covered in the previous lesson. If you ever asked about the turning point, it's generally a good idea to complete the square. Okay. The other thing is that if there are no intersections for this, if there are no roots, which there are for this one, but if it wouldn't factorise or the quadratic formula wouldn't work, then completing the square will be the only thing that can tell you anything about it. I'm going to use completing the square on this because it asks for the turning point. You should try to make sure that completing the square is one of your big strengths. So we have x plus 3 all squared minus 1. All right. Now this tells me that the turning point is going to be -3, -1. We can also work out the intersections with the x-axis, the roots of this function. So we've got x plus 3 all squared minus 1 equals 0. X plus 3 is going to equal, well, move that over, make it positive, root it. So we end up with plus or minus root 1, which is plus or minus 1. And so we end up with x equals -3 plus or minus 1. X equals -4 and x equals -2. Okay, those are the roots of this quadratic. And to draw this quadratic, dead easy, we've got it's x, y. Okay, if this was f of x, you'd have f of x up there. It doesn't really affect too many things really. -2, -4, make sure you get those in the correct order. -3 is going to be here. -1, make sure that, again, that your roots halfway between them will be your turning point, and our y-intercept is all the way up at 8. That can be found in the original equation or function. So we've got our quadratic looking a bit like that. Okay, I should have mentioned this was going to be U-shaped because there's no negative there. If there was a negative there, okay, then it would be N-shaped. And also it asks for the line of symmetry. Now the line of symmetry would equal to would be x equals -3. X equals -3 goes through there like that. All right, let's move on. Sketch the quadratic indicating all intersections with the axes, the turning point and the line of symmetry. Again, I'm going to complete the square, so y is going to equal x plus 1 all squared minus 1 plus 11. Which will be y is going to equal x plus 1 all squared plus 10. So my turning point in this case is going to be -1, 10. Now sometimes it's a good idea when you find the turning point straight away to say, well, -1, 10 would be up there. This is going to be a U-shaped quadratic with a y-intercept up at 11. So it's going to go like that. So will there be any solutions to this? Will there be any roots to it? Well, no, of course there's not. And you can check whether there's going to be any roots to it by dealing with x plus 1 all squared. Assume that there are roots. And you very quickly end up having to do x plus 1 equals plus or minus the root of -10. Okay? No real solutions. And you'll see the words no real solutions really often. And you'll be thinking, well, why is the word real in there? Surely that seems like something kind of extra that's not necessary. Well, root in a negative would take you into the realm of imaginary numbers. So there are imaginary solutions, but there aren't real solutions. Or there are complex solutions, and there aren't any real solutions. You don't really need to worry about it. If you're trying to root a negative, you don't get any solutions for your intents and purposes. Okay, moving on. Again, we want the turning point, so I'm going to complete the square on this. You might need to look back onto my lesson about completing the square. So we're going to have 3 lots of, well, this is going to be x squared plus 2x. Don't really need 2 pairs of brackets there, but I'm going to be using them in a second anyway. So we've got y equals 3 lots of x plus 1 all squared minus 1 plus 2. Multiplying your 3. Remember though, make sure that you multiply that -1 by a 3. Make sure you multiply that as well, because that's what people get wrong. There we go, and we end up with y is going to equal 3 lots of x plus 1 all squared minus 1. So my turning point is going to be -1, -1. This is U-shaped. -1, -1 like that. we've got a y-intercept up at 2. So we know there's going to be two solutions. We know they're also both going to be negative. Alright, so we'll find out what they are now. So we have y equals 3 lots of x plus 1 all squared minus 1. So finding the roots of this, we'll have y equals, we'll have 3 lots of x plus 1 all squared minus 1 equals 0. X plus 1 all squared will equal 1/3. The 1 went over and the 3 went over. And we'll end up with x equals negative 1 plus or minus root 1/3. Okay? You can rationalise that if you want to. You can chuck that into your calculator and get something out that's a little bit nicer. For me, I'm happy with what I've got, but you could rationalise that. And so what you can say is that this one here will be the one with the plus. Okay, so we have negative 1 plus root 1/3, and we'll have negative 1 minus root 1/3. Those are the exact values. In this question, it doesn't ask for exact values, so you could round it to 2 decimal places if you wanted to. Okay, but those are the exact values, and I quite like them. I think they're useful to have. What you'll also note is that whenever you get this form here, whenever you get a value plus or minus, that value should be the same as the x part of your turning point. Okay, that's really important to notice, because what's happening here is you've got negative 1 there, and this is being dragged by root 1/3 each way, so negative 1's in the middle. Line of symmetry. X equals negative 1. Alright, moving on. Sketch this thing. Now, to sketch this thing, we're going to try and do as much as we possibly can with it, but look at it. It's in the wrong order, I suppose. And you could say, well, you've got y equals negative x squared plus 7x minus 2. But also it's n-shaped, so it's going to be a little bit more difficult to solve. Now I want the turning point, so I'm going to complete the square on it. Y equals negative 1 lots of x squared minus 7x minus 2. I'm going to complete the square in here, so we'll have y equals negative 1. Oh, watch out for that sign change as well. So that plus there, it turns into a negative because of this negative here. So we'll have x minus 7 over 2. You can give it as 3.5 if you want. Minus 49 over 4 minus 2. Y equals negative of x minus 7 over 2 all squared plus 49 over 4 minus 8 over 4. Okay, all I've done there is when I multiplied in here and I got the positive 49 over 4, I've also converted that to quarters. Okay, it just makes things a little bit easier for me to tidy up. So I'll get y equals negative of x minus 7 over 2 all squared plus 41 over 4. So my turning point therefore is 7 over 2 and 41 over 4. Now, take a look at how that goes. Where does that live? So we've got 7 over 2 and we've got 41 over 4. It's going to be off up here somewhere. Alright, our y-intercept is going to be negative 2. So we'll have something that looks a bit like that there. Okay, so we're going to expect two solutions, and they're both going to be positive, we'd expect. Okay, also because this is a negative here, we've got an n-shaped curve. Okay, so we need to find our solutions for it. So let's have a look. We've got negative of x minus 7 over 2 all squared plus 41 over 4 is going to equal 0. We'll move this over, it becomes negative, move the negative over as well, and then we're going to root, we'll do all that in one go. X minus 7 over 2 is going to equal, this goes over, becomes negative, the negative multiplies through by it, so we end up with 41 over 4, and then we're going to root that, so we get plus or minus root of 41 over 4, which give us x equals 7 plus or minus root 41. The square root of 4 is 2, so we can combine these two denominators. Okay, I can root this to get root 41, I can root this to get 2, so I'll actually end up with x equals 7 over 2 plus root 41 over 2. So we can put an over 2 there. Alright, so our two solutions are 7 plus root 41 over 2 and 7 minus root 41 over 2. Okay, the line of symmetry, x equals 7 over 2. There it is, 7 over 2. Okay, so we've got all the stuff that we were expecting. It's just a little bit more difficult in terms of you completing the square. All right, let's move on. So give the equations of these quadratics in the form y equals ax squared plus bx plus c. So these are weird questions that you see quite often. Now, in this case, look at the roots first. We know that we've got something that is something to do with x plus 4 and x plus 2. Now, a in this case is just a scalar. Okay, it's some scalar on it that might help us to produce the negative 8 somehow. Okay, in actual fact, we've got oh, sorry, there we go, there's your problem. Okay, that should be minus 2 there. Okay, so what we actually get is y equals a lots of, well, this stuff all expanded out would be x squared plus 2x minus 8. To produce this negative 8 here, a would need to be 1. So we have y equals x squared plus 2x minus 8. Okay, not too bad. All right, let's move on. In this case, we have y equals some scalar. I'm going to call it b this time. It doesn't really matter, really, to be fair. It could be a little bit confusing, though, because of this a, b, and c. So I'll go with r, why not? So we'll go r, lots of, well, that's x plus 1 would produce that, and x minus 5 would produce this bit. So we have y equals r, lots of x squared minus 4x minus 5. But I want the y-intercept to be negative 10. So r must equal 2, because then I'll have 2x squared minus 8x minus 10, which will give me my y-intercept, which will be correct. Okay, so we have y equals 2x squared minus 8x minus 10. Okay, here, a little bit more awkward, but again, similar sort of thing. We've got y equals r lots of x plus 3, x minus 3. So y equals r lots of x squared minus 9. But I want it to be up at 18. And to do that, r must equal negative 2. Negative 2 lots of x squared minus 9. And so what you end up with is y equals negative 2x squared plus 18. These aren't overly difficult. Just produce the bracket first. Would always be my my advice. Produce the brackets, and then multiply however you need. Next, y equals r lots of. Now here, this is an example of something where you've got the same solution twice. Okay, and you should recognise from GCSE that you've got the same bracket twice. Okay, so y will equal r lots of x squared minus 10x plus 25, but we want 75, so r must equal 3. So y equals 3x squared minus 30x plus 75. Okay, not too bad, pretty manageable. All right, let's move on. Give the equation of this quadratic. This is far more difficult. Now look at the difference between this question and these questions. In this question, you're not being given the solution, you're being given the turning point. Okay, now this is nowhere near as easy to deal with. We don't know this and we don't know this, and so this is much more difficult. All right, so to deal with this, what we have is we've got our turning point already known. Okay, so we know that we have y equals r lots of, well, we have x minus 4 all squared minus 3. Okay, but that negative 3 there should really be outside of the bracket, so we'll get rid of that. There we go. Because really we want r to affect this stuff here, and for us to still be left with a negative 3 at the end, guaranteed. Okay, now when we expand out this stuff and we expand in the r, we end up with y equals r lots of x squared minus 8x plus 16 minus 3. And so actually the quadratic looks a bit like this. 8rx plus 16r minus 3. Okay, that's how the quadratic would look. We don't know what r is just yet, but we do know that 16r minus 3 must equal 13. Okay, these are the only bits without x's, so these will be the y-intercept. So you'll have 16r is going to equal 16, so r is going to equal 1 in this case, and so y equals, you can give it as either this form, or you can give it as this form. It would be x squared minus 8x plus 13. Okay. Thanks very much for watching. Visit numberclub.org to find some more videos and tasks just like these ones, and if you get a chance, please subscribe to the channel. Thanks very much.